Okay, so we are on Unit 1, which is an introduction to software engineering. What are the learning outcomes for this particular unit? It's very important to read the learning outcomes when you start a study unit because they help you to reflect, okay? They help you to reflect. Remember, the assessments are set on the learning outcomes. So make sure that after each study unit, each learning outcome is indeed satisfied. So the first outcome is outline the importance of software engineering during the software development process. Apply software engineering tools, techniques, and methods in a specific environment. Evaluate and discuss various types of software. And then the last one is have a thorough understanding of ethics of an organization and professional issues which are important to software engineers. Those are the learning outcomes. So, introduction to software engineering. The first question you ask yourself, what is software? It may sound like a simple question, but how do you answer it? We know software is it's intangible, cannot feel it. Okay, so how do you define it? They say it's a set of computer programs and associated documentation. What do you regard as good software? It delivers the required functionality and performance to the user and should be maintainable, dependable, and usable. So a lot of people, they tend to develop software, but it just doesn't meet the user's needs. Your software can look very good, but if the people that are the target users, they aren't satisfied with its functionality, then they're not going to use it. So in essence, we say good software is software that obviously meets, in terms of functionality, meets the user's needs, and it's maintainable, it's dependable. Let's see, let me just submit the person. It's dependable and it's usable, okay? Now, software engineering, those two words, when you join them together, okay? In actual fact, we're breaking it down so that we're able to understand it better. We've defined software and what makes good software. But now when you talk about engineering, engineering is a very generic term given to a specific field of study. And it is a systematic, scientific, and well-defined process to produce a quality or good quality software. Now, the reason why we apply engineering to software, in actual fact, the reason why we apply engineering to any field is to ensure that when you're building a product, you follow good practices that have been proven to work in the industry. In this particular case, we're talking about software. So there's tools, there's techniques, there's approaches you can use to developing software. They've been tried and tested, and developers have seen that these processes or these standards produce a good product. So the whole field of software engineering is based on that. How do we manage this process of developing software so that at the end we get a good product? Okay, so the characteristics of these products, as we mentioned in the second point, is that maintainability. What do they mean by maintainability? It should be written in such a way so that it can evolve to meet the changing needs. Remember, your environment around you is constantly changing. Your customers' needs is also constantly changing. So when we talk about maintainability, we mean we have people who are able to make the software evolve with this dynamic environment. Dependability and security. Can you depend on the product? If it's a good product, you can depend on it. And that ties in with the aspect of security. I mean, if something is not secure, then you can never depend on it. Just imagine you are trying to use some sort of banking software and there's no encryption, there's no digital certificate. You cannot depend on something like that with your money, okay? Because at the end of the day, it's your money and your data as well. So it includes a range of characteristics, including reliability, security, and safety. And the third point, efficiency. Good software must be efficient, okay? You may code it to look good, have all the features, but is it built efficiently? And that boils down to how you actually write the algorithms. Because sometimes you download the software and it's just using up so much of your computer resources, okay? You need to optimize the software, build it in an efficient manner. We understand that you built it in a works, but is it efficient? Otherwise, it's going to end up taking up the user's memory and processor speed, okay? So how do we then define software engineering? And this guy, Somerville, is the author of the prescribed textbook, okay? And this is how he defines software engineering. He says, software engineering is defined as an engineering discipline that is concerned with all aspects of the software production from early stages of system specification through to maintaining the system after it has gone into use. Guys, may I just ask that whenever your colleagues log into the meeting, just admit them in because they'll be in the lobby. Okay, so according to Somerville, that's how we define software engineering. So in the test and exams and so forth, get used to defining software engineering according to how Somerville does, because that's the prescribed textbook. That's what's in your study guides as well. Types of software products. So we have two main categories of software products. We have what we call generic product or generic software. I know when you did, you may have done doc analysis. And in doc analysis, we learned that we can refer to it as a horizontal system. Generic products are horizontal systems because they can fit into any organization. So they are standalone systems which are developed by vendors for sale in the open market. Example, picture Microsoft Office. Any organization can go into the store and buy Microsoft Office for use. You don't have to be doing anything specific or anything special. It's a generic product. You buy it off the shelf, you purchase it off the shelf. As opposed to the second category, which is customized software. With customized software, we build it around a particular problem domain. So there has to be something going wrong in the company and it has to be unique to that company, which means we cannot sort of outsource any solution off the shelf for this problem. So we need to customize the solution, custom build it for the organization. There are pros and cons to both, okay? For example, if you are looking to get a generic product, you cannot customize it for your organization to suit your needs, okay? However, generic products are readily available off the shelf. For as long as you have the money, you can get them to your customers quicker, okay? And with customized software, it can get very expensive because you're building the solution from scratch, which means you're going to have to pay developers to work, put in those hours, building it, maintaining it, and so forth. You can picture with generic products, Microsoft is in charge of Microsoft Office. You, as a company, you don't have to do anything. You just install the updates. But with customized software, it is your duty to do so. Okay. The benefit of customized software, as we said, is that you produce or you bring to the market a solution that meets the customer's needs. Okay. So what are some of the advantages of software engineering? It is cheaper to use software engineering methods in the long run, since most individuals and societies rely on advanced software. You know the saying, if you do something right the first time, then you don't have to keep on repeating it in the future. Because what could happen is that you build software, but not according to the software engineering principles. And then that will cause a problem for you in the future because it will just keep on breaking. And then all you're going to keep on doing is that you're going to keep on coughing out money for maintenance. Okay, so do it right the first time so that it doesn't become a liability in the long run. And then it is reliable, efficient, trustworthy, and economically sound systems must be produced by software engineers. If good software engineering practices are not followed, this could lead to higher costs for testing the software, quality assurance, and long-term maintenance. And that ties into the first point as well, is that you'll be stuck on the, according to the SDLC, which you should be familiar with at this stage as exit level, you're going to be stuck in that testing phase of the SDLC, and it's going to be hard to move away from it because there's so many issues. And now you're going in iterations trying to fix all of these issues because of a lack of planning. It's like when a friend says to you, I'm starting a company, can you build a website for me? And then the first thing you do is you open up Notepad and you start coding away. You may end up forgetting, yes, it's just a 5-page website, but if it's an advanced sort of web-based system, you may end up forgetting certain things. You may end up forgetting certain things, and then you're going to have to keep on going back. Or you always start from the first phase. Make sure you understand the requirements, do your modeling, draw your system out properly, and you won't go around from there. Okay, so these are the advantages of adopting software engineering processes. Fundamental activities used in the software process. I think these processes basically sum up what the SDLC is. The SDLC, yes, it's a model, and there's different versions of it, but you need to understand these processes in summary. And the first one they talk about is software specification. If you are trying to do software specification, you're trying to find out what is the client trying to achieve by building the software. Okay, so what are the requirements? What are the user requirements? And this, according to the SDLC, would be the requirement analysis, as we know. And they say here, this is the stage where software engineers and customers sit down to define the software to be produced and the concentrate of that particular software. In the later study units, perhaps we'll touch on these different phases and the different techniques we can use to get these requirements from our customers. So after the software specification process is done, there is a document that is generated. And this document is called the specification document. With the specification document, you then take it and you give it to the developers, okay? Because the developers need some sort of blueprints before they start coding. They don't just code these systems from the top of their head. They need to follow this plan. So with the specification documents, the software developers during the software development process will start coding away, okay? And then we have software validation. Software validation. It says it is a process of detecting errors to ensure that the system meets the customer's needs or expectations and requirements. Verification and validation are used. There is a different SDLC model called, you may have not seen it because it's a third year thing, but it's called the V model, okay? I know in the previous years, we went through the traditional waterfall approach and the spiral model. Now, there is another one called the V model, and in the later study unit, we'll look at it, but it's very useful when you want to do software validation, okay? Software validation is done at the testing phase because what you are doing during validation is that you are measuring what you delivered and what was supposed to be delivered during the software specification phase where the customer told you what they were expecting. So you're measuring what you delivered, and you're also measuring if what you delivered actually works. So that's what happens during software validation. And then we have software evolution as well. We say software doesn't stay the same. It has to change with the environments that we are in. As your customers or your organization grows, your software will also evolve after some time. Maybe now you're growing as a business and you're adding more employees. There's a need for the software to be able to accommodate all of those people in the organization, okay? And attributes of software. Let me just see if okay, we have 16 people. Okay, no questions, everything is still fine. So right, so attributes of software. Software must be acceptable to specific users, and it must be understood by the target users. As we said earlier, you build it according to your target market, and you have to understand how they operate or how they do their work. Otherwise, then nobody's going to use that software. Software systems must be secure. Security, big concern. Everybody must be paranoid with their security. I mean, a security breach, you lose your data, people end up hacking you and stealing your money. So I'm sure we can all agree that software security is very important, because trust me, there are hackers out there. It's not only in the movies, they do exist. So many companies have been hacked before because of lack of security in their software systems. They've been hit by different malicious software and even ransomware. So software must be efficient in terms of response time, processing time, and throughput. And what this means is that if I'm using your software and I click on a button, but I get the response after 5 minutes, I'm just going to close that software and not use it anymore. I'm going to download a different software. So speed is everything, okay? Efficiency is everything. Remember, I said earlier on, you optimize your software. And by optimizing your software, it means it's going to be using less processor and less memory. And when it's optimized, it means it will function faster, okay? And then good software must be maintained so as to accommodate the changing needs of the customer. We already spoke on that one. Your customers are constantly changing needs, expectations from you. And that's why most of your software on your computer always have updates. That's the reason why you have updates, so that it's able to adjust to the needs of the customers. Issues that can affect different types of software. So heterogeneity, what is that? What does that mean? It's whereby a certain system operates across several networks, which include several types of computers and mobile devices in a distributed system. That could be a very big challenge. Here you are, you have a software, and within the environment at which the software is operating, there's all of these different devices. We have, for example, let's say we have Android devices, we have iOS devices, we have BlackBerry devices. How does your software accommodate for everybody? Because everybody must get the same experience. This goes back to the architecture you end up adopting. Because if you look at companies like Facebook, with their systems, whenever a new platform is introduced into the market, they are able to produce a solution as quick as possible. That's because the way they built it initially allows them to do that. There's a lot of flexibility. So these are the issues that you're going to have, where your software needs to accommodate these different devices. Remember also these devices are in different sizes. We have laptops, we have tablets, we have devices with small screens and so forth. So you need to accommodate everybody, and each device is processing the data at its own speed. So it's not easy. One of the workarounds is that developers tend to build the software based on web technologies. So what they do is they build it similar to websites. Although on your computer or on your phone, it may look like it's a native application, but they actually built it around web technologies. Remember, web is supported regardless of any platform. I mean, modern operating systems are able to support web technologies, HTTP. So that's what companies like Facebook do. They build it around the web technology so that when a new platform comes out, all they have to do is create a canvas, and on that canvas, for example, to accommodate Android. So everything is sort of just a canvas, and then the web technology is within that particular canvas. So that architecture actually works for developers, and it ensures reusability. So business and social change is whereby businesses and society change as emerging economies and new technologies become available. There is a need to change existing software and to rapidly develop new software. That is true. Society changes, the world is changing. Picture these new concepts that they talk about, like cloud computing. You need to be able to adjust so that you remain competitive. Okay, so if your competitor is now using the cloud to power their systems, remember the cloud can adjust, it can scale. When you're having a lot of usage, it will scale for you. And you're still operating in the traditional way of doing things, which means you have your local database, you have your software, which is not safe, by the way. So you have your local software and your local databases, and then something happens in your organization and then you lose everything. So be able to keep track of how is the business environment changing? What are your competitors doing? What's changing socially? Okay, what's changing around you? There's emerging economies, there's new technologies that are becoming available. Make sure that you're able to adjust to that. And then security and trust. Software engineers must enforce security so as to guard against malicious users and unauthorized access. You may think that malicious users come from outside. When you talk about hackers, or crackers, you may think we're talking about people mostly outside the organization, but these people can also come from inside the organization. What if an employee gives the credentials of another employee with malicious intent? That becomes a problem, okay? So forcing users to create strong passwords on your software, making the passwords expire after some time, those are some of the practices at which you can adopt to make sure that there's security and trust in your system. And then the last one is scale. Software systems must be developed across a wide range of scales that are from small embedded systems to internet scale, cloud-based to serve the global economy, and as well globalization. If you may be trying now to target a global clientele, and you're going to have more users, because you may be operating in South Africa only, but then once you want to go globally, now you're opening up your systems to a broader audience, okay? And scalability is everything. And I did mention the use of the cloud to scale, and that's what it's for. Dynamically assigning you these resources because you cannot do it yourself. That's why most online companies end up crashing, because they cannot handle the load on the busy seasons like Black Friday and so forth. So by using the cloud, your software or your systems are able to scale effectively, especially if you plan on expanding and going globalizing and so forth. What are some of the types of applications that we find? We have standalone applications. When we talk about standalone applications, these applications don't require any form of network connections in order to operate. Microsoft Office doesn't require you to have internet connection before you can use it. That's an example of a standalone application. The Notes or Notepad or the Notes app on your phone, it doesn't require any internet connection to use that app. So we refer to those as standalone applications. Then we have interactive transaction-based applications. These applications basically are remotely accessed, and they enable you to process transactions in masses. So they can handle a large volume of transactions remotely as well. Well, then we also have embedded control systems. Sorry about that. Embedded control systems. if you picture the way your printer operates, embedded systems are there to control hardware. And the system that's installed onto your printer is an example of an embedded control system because it's there to control the hardware, which is the printer, right? So that's example of embedded control systems. Then we also have batch processing systems, most popular in the retail sector, where they're not going to be processing each transaction individually. It's going to cost them too much. If you go to Pick n Pay and you go to pay and you use your card, they're not going to process the transaction same time. Yes, your account balance will change, of course, but they're not going to process the transaction. It's going to be pending. It's going to be pending. And what they normally do is they do everything at the end of business day so that they don't get charged a lot on the fees. Okay, so that's what batch processing systems do. They batch process a lot of transactions simultaneously. Then we also have entertainment systems. Entertainment systems, your consoles, gaming consoles, and so forth. All of those make use of entertainment systems, the software on your gaming consoles. Systems for modeling and simulation. If you're going to be building a house, you're not gonna, that's the old school way of drawing on paper. You're going to be using software now. You may have heard of AutoCAD. AutoCAD is an example of a system for modeling. You need to model the house, build a model of the house, which forms part of it, of the plan of the house or the architecture of the house. And there's also systems for simulation. Okay, how do pilots learn to fly planes? They have to do some sort of simulation, and that simulated environment is controlled by software. The conditions are set out by the software. So there are systems for modeling and simulation as well. Then we have data collections and analysis systems. These type of systems are normally used in conjunction with some sort of sensor technology. So it's a combination of sensor and software. Commonly used in, like, for example, aeroplanes. Aeroplanes have onboard sensors which report to the pilots on the conditions of the plane or the weather conditions or the altitude at which the plane is flying at and so forth. So that is tracked by some sort of software on the plane, but the software cannot do that without some sort of onboard sensor that's reporting constantly to it. And lastly, we have systems of systems. Example of this would be your ERP systems. ERP systems are built to sort of aggregate our data. So our organization is running all these different subsystems, but how do we take the data sources from those different subsystems and bring them together? And that's what an ERP system does. So hence, we refer to it as a systems of systems. So these are the different types of applications we find. And moving on, software engineering ethics. As a software engineer, you're expected to act ethically, of course, but they don't always do so. And the first one is confidentiality. So what does that mean? If a customer comes to you and says, I want you to build me a software, we already have an existing one and it's just not working well. So they give you access to everything. They give you access to the old software and they give you access to their database as well, okay? And then you remember that database is confidential. They gave you it to be able to build the new software so that you do not share that information with other organizations. So confidentiality is very important. Respect confidential data. Do not share the other company's data with other competitors or any third parties. The next one is competence. Okay. What this means is that you must not misrepresent yourself. If you cannot do the job, you cannot do the job. A lot of people in the software field, they tend to misrepresent themselves. If you only understand Java, it's fine. You must state that you only understand Java. Don't try to code in C#, okay, or misrepresent yourself as being able to code in C#. So that's what they mean by competence. And then we have intellectual property rights. What do we mean by intellectual property? It's creations of the mind. So I create something, I invent a software, I license it, I own the code. I put it out there for people to use only, and they have to buy it from me before they can use it. Because I own the IP rights to it. Nobody else has the right to make changes to it. So most of the time in software, we use third-party plugins in our software. We reuse other people's developed frameworks, okay? Even when it comes to the open source, we have open source and closed source. Even with open source, there's only limited things that you can do with that software. You can change the code, but you cannot resell it as your own. Okay, so that's what open source is all about. And intellectual property, in terms of open source, they give you that freedom, but even there, it's limited. So you are expected as a software engineer to respect the intellectual property rights of other developers as well. And the last one is computer misuse. If you're working at a software development firm, make sure that you do not misuse the resources. Most of the time, people end up watching YouTube or downloading movies and stuff like that. That's computer misuse, okay? So as a software engineer, you are expected to act within the bounds of your ethics, okay? And in conclusion, we only have about 3 minutes or so left. So in conclusion, software engineering is essential in all modern organizations since all the utilities and infrastructure are controlled by computer systems. So what they are saying here is that remember that in the modern world, everything is controlled by software. That's why when you go to an organization and they say they're offline, it's because the systems are down and they can't do anything. So it's essential, since we rely so much on systems, it's essential that we adopt software engineering processes to ensure that we minimize the amount of downtime. There are several types of systems which can be used. However, there are no universal methods, tools, or techniques which can be applied, since types of systems require different approaches to systems development. That is true. There's no one particular framework or approach that you can say you're sticking to as an organization. It depends on the type of project you have, how complex it is, and that determines the types of tools, methods, and techniques that you end up adopting. Okay, so the tools, techniques, and methods are per project, and not, you can't adopt them generally for the organization. To say that no, we are traditional, we use the waterfall, we only code in Java, that doesn't work, okay? And then generic products or customized software are two types of software products. When choosing software products, one needs to consider the essential attributes of good software and also the user requirements and the system's requirements. Software engineering is guided by social and legal frameworks which limit the freedom of people working in the organization. Yes, there are some sort of industry standard, the ISO organizations, which define these standards and regulate these standards. And so software engineers are expected to act according to social and within the legal frameworks as well. And lastly, there are 4 software engineering ethics, which we talked about: confidentiality, competence, intellectual property, and computer misuse. Okay, so that is Unit 1 in week 1, and we covered the topic introduction to software engineering. Okay, so let me just stop the recording.